Let's build a low-latency streaming pipeline using SRT as a source and WebRTC WHEP for viewing. We're going to send an HEVC stream from a mobile device, transcode it into an adaptive bitrate ladder in Nimble Streamer, and deliver it to browsers using the WHEP protocol. This setup gives us low latency and high efficiency. You may use any other source protocol supported by Nimble Streamer for such a setup. Before we start, a few prerequisites. This tutorial focuses on workflow configuration, so we will not cover the initial installation of Nimble Streamer, SRT library, or the Transcoder add-on here. We assume you already have a functional setup in place. If you're starting from scratch, please refer to our official documentation and dedicated installation videos, which walk you through the setup process on various platforms. Here, we ensure that the latest Nimble version is installed. A quick note on the licensing requirements. For this workflow, we assume you have the necessary licenses in place. This includes an active WMS panel subscription to manage Nimble Streamer, the Transcoder add-on subscription, and the Larix Broadcaster for your mobile source. For WebRTC and WHEP to function in modern browsers, an SSL connection is mandatory. You'll need to enable HTTPS for your Nimble instance. Switch to the server's console. In your nimble.conf file, specify the SSL port, usually 443, and provide the full paths to your SSL certificate and SSL certificate key. In this tutorial, a self-signed certificate is used, and we have to manually accept the security risk in our browser before we can see the stream. Next, you need to enable the WHEP feature by editing the same Nimble configuration file. Add option WebRTC WHEP support equals true to enable WHEP playback. After saving these changes, remember to restart the Nimble service. Here, on the server info page, we can check whether WHEP is available now. Next, we need to define an application that will bridge our SRT feed to our WHEP viewers. Go to Live Stream Settings, Applications, and click Add Application Settings. In the application name field, type WHEP. It is important that this name exactly matches the one we will use later in the Transcoder Wizard to ensure the streams are routed correctly. To secure your incoming connections to this application, we advise you to enter a push login and push password. The most important part of this dialog is the Protocols section. You must check the box for WebRTC WHEP. This specific setting enables the WHEP egress protocol for the application, allowing Nimble to deliver the low-latency WebRTC streams. Leave all other options on defaults for now. Click Save to apply the settings. Inside WMS panel, go to Live Streams, Settings, and then MPEG-TS-IN. Add SRT stream. Choose Listen for the receive mode and an unspecified IP address in the local IP field. Fill in the same local port you will use in Larix. Let's say 49001. Add description and tags if you like. Fill in the latency and max BW parameters according to your network capabilities. Name outgoing application as incoming and stream as SRT. Click Save to sync settings with Nimble. Nimble Streamer is ready to receive the SRT stream on port 49001. Now, let's set up the source. Switch to Larix Broadcaster, create a new SRT connection. Enter your server's IP or domain and port. Don't forget to specify the latency parameter. It is basically the buffer for sending and receiving data. Lowering it will allow less latency, but estimate your network capabilities before setting a low value. Refer to Haivision docs about calculating the latency parameter based on RTT between sender and receiver. Go to Video Encoding Settings, tap Format, and select HEVC. Using HEVC for the contribution link saves upload bandwidth while maintaining high visual quality. Larix can stream HEVC by many other protocols, including industry-standard low-latency NDI. Now we can start streaming. Once the handshake is complete, you'll see the incoming stream appear as active in your inbound streams list. Now we have our SRT 1080p HEVC source ready for processing. To handle different client network conditions, we need an adaptive bitrate ladder. Instead of building every filter manually, we'll use the Transcoding Wizard. Select Transcoders in the WMS panel menu and click Transcoding Wizard button. Choose Adaptive Bitrate Streaming and click Next. Enter a recognizable name in the Transcoder scenario name field, such as WHEP ABR Tutorial, which will help you identify this specific scenario in your list later. In the Source Stream section, you need to tell Nimble exactly where to find your incoming feed. Enter incoming for the application and SRT for the stream name, matching the identifiers we set up for the inbound SRT connection in the MPEG-TS-IN outgoing stream section. Next, you define how the processed outputs will be named for your viewers. For the ABR application name, type WHEP to keep these streams logically separated. In the ABR stream name field, use a prefix like ABR_tutorial. The wizard uses this name to combine the different quality levels it is about to generate. On this screen, we configure the specific encoding parameters for the adaptive ladder. First, make sure the Optimize for WebRTC checkbox is selected, as this tells to create a scenario with WebRTC compatible codecs. For the video encoders, we have both libVPX and libH.264 selected to provide the best balance of efficiency and browser compatibility. Moving down to the output streams table, the wizard has automatically generated 3 distinct renditions for us: SRT 1080p, SRT 720p, and SRT 480p. For each of these, the scaling logic is set to scale height, keep aspect ratio, which ensures the video remains proportional regardless of the target resolution. You can see the vertical resolutions are already filled in as 1080, 720, and 480 respectively. If your project requires more qualities, you can simply click Add Resolution at the bottom to expand the ladder before hitting Next to finalize the setup. Finally, we reach the confirmation screen, which summarizes exactly what WMS panel is about to build for us. Once we hit the Finish button, the system will create the WHEP ABR tutorial transcoder scenario to generate the adaptive resolutions we just defined. It will also automatically establish the ABR setting at the path WHEP/ABR tutorial. You also have the options to pause the new transcoder scenario if you aren't ready to go live immediately, or enable out-of-process mode for enhanced system stability. Refer to Transcoder's docs for more details about it. Once you are satisfied with these final details, simply click Finish to complete the setup. As you may see, the complex scenario was generated for the required ABR ladder. The initial resolution is scaled, and the required renditions are set with specific codecs. Sure, you can fine-tune them for your quality or other requirements. Now, go to Live Streams, ABR. You already see the ABR group specified, but you may also see how it is constructed by pushing the wrench icon from the left. To get the WHEP ABR streaming URL, click on the question icon and select the WHEP stream. You will see it running if all is fine. Copy the URL of the ABR stream here. WHEP is designed for standard web browsers. Your viewers don't need a special app. They just need a WHEP-compatible player like the Ivan Player fork we offer on our test page. Paste the URL into the test player. You'll see the stream starts almost instantly. If we throttle the network, the player switches between our transcoded qualities automatically. The delay is as fast as technically possible, making it perfect for interactive live content such as sports, live concerts, or gambling. With WHEP and the transcoder up and running, your stream is live and can be watched in any modern browser with near-instant playback. The HEVC feed over SRT is now converted into an adaptive stream that adjusts to each viewer's connection. This setup keeps your upload costs low while ensuring your audience sees the action exactly as it happens. Please check the links to all related documentation in the description below.